Hello and welcome to NHP's live webinar on integrated condition monitoring. We'll give folks another minute to log on and then we'll get straight into it. Good morning, everybody. My name is Evan Willemse. I'm an application engineer for NHP Electrical Engineering. We are excited to be presenting on our new webinar platform today, and we trust that you will enjoy the experience. Clicking on each of the icons located at the bottom of your browser window will hide or show the relevant function. During the presentation, if any media is played, it'll automatically maximize while playing. If for any reason it doesn't, you can simply click on the icon to bring the relevant screen back into view. Please use the Q&A section to submit any questions, and of course, we'll be happy to address those at the conclusion of today's webinar or via one of our friendly moderators on the go. This is just one in a series of webinars created to showcase the smart devices provided by Rockwell through NHP, giving our customers better visibility into processes, data, and analytics. The goal for today's webinar is to cover off the following key points: maintenance practices, condition monitoring categories, vibration analysis, predicting failure by trending fault indicators, manual data collection. We'll talk about what makes a condition monitoring system truly integrated, baseline values, and we'll also show you an example topology. So in any plant, we all have assets that, of course, we need to protect from damage, reduce maintenance costs, and prevent problems that will result in a loss of production. I'm going to run through some common, they are obvious practices, but these make up an overall plant strategy for maintenance. The good old reactive or run to failure. I'm pretty sure that there will be a few people on the call that have got the call at 2 a.m. in the morning saying that it's broken and it's not working. Now, that's fine when you're dealing with a non-critical asset. A pro of this is that it's low cost because you're waiting for it to break. But a massive con is that we obviously have no control over when equipment fails. And if there are high risks to production, there's also other things like secondary damage. Anyone that's fortunate enough to own a vehicle will understand preventative or calendar-based maintenance. This is done on planned periods, and obviously a pro of this is that a risk of early failure is much less than a risk of wear-out failure. But it's high cost and it's wasteful, as parts are often replaced before they need to be. Now, the next statement might be provoking. Anyone that's lucky enough to own a Tesla vehicle will understand predictive maintenance or condition-based maintenance, your system telling you when it needs to be maintained. It's monitored using different techniques, and a pro of this is that repairs and maintenance are only carried out when required, and you're able to plan for that maintenance period. A con is obviously the initial installation cost for online systems and the ongoing monitoring costs. Somebody needs to take care of the system. So let's take a deeper look into the predictive category. Now, condition monitoring is essentially the process of monitoring parameters that are indicative of conditions in machinery in order to help detect and then identify developing faults. A condition monitoring system provides the sensing, measurement, alarming, presentation, and analysis tools necessary for helping detect and identify developing faults. The goal of a CMS or a condition monitoring system is simple. It's to maximize availability while reducing operation and maintenance costs. Knowing that there is a problem, what the problem is, and how serious it is can allow maintenance to be performed sooner, quicker, at a reduced cost. This also will prevent potential collateral, or more extensive damage, unexpected downtime, or possibly reduced product quality. So each one of the subcategories of condition monitoring shown here on the screen is a science on its own. Today, we're going to be looking at vibration specifically. Now, I know that I'm not the only one on the call today that modified my push bike as a child. I know that there's probably some older people on the call that are still modifying more expensive bikes. Now, I'm actually convinced that that popular MTV show, Pimp My Ride, that it was started with a bunch of kids modifying their push bikes. Now, a favorite modification when I was a child was to steal one of my father's playing cards, usually the Joker or the Ace of Spades, and attach that to the fork of the bicycle by means of a clothes peg or a zip tie, so that my push bike made a realistic engine driving sound when pedaling along. So thinking of the sound that it made, it's basically just a popping sound. Let's say we switched it around and we attached the playing card to the spoke instead of the fork. Essentially, you would only hear one pop per revolution, and depending on the speed that you were going would determine how often you hear each pop. So if you were just cruising along and your friend or your older sibling came flying past you, you would obviously hear a faster popping pattern. So the rate of these popping events per second is called the frequency, and it's measured in hertz. So shown on the screen over here, on the left-hand side, the raw time waveform essentially contains all of the popping sounds combined into one raw time waveform. And the process to go from the left-hand raw time waveform to the right-hand frequency spectrum is carried out by using some really clever maths called a fast Fourier transform. So relating to machinery, we apply the measurement of vibration at various points on the machine by attaching an accelerometer at a strong transmission point to supply the time waveform. The fast Fourier transform then converts the raw signals into specific frequencies at their respective amplitudes. This makes it possible to measure the frequencies that indicate specific faults. Monitoring these frequencies makes it possible to assess and trend a machine's condition relative to specific faults. Because faults induce repetitive impact or cyclic forces at specific, predictable frequencies, and these are related to the machine, speed, mechanical, and or electrical attributes. So to understand what is causing the vibration, we can simply monitor the fault indicators. Fault indicators are the magnitude and sometimes the phase values of specific frequencies of vibration that are caused by mechanical, electrical, or process conditions. Now that we're looking at a spectrum, essentially just a 2D view of the right-hand side of the 3D drawing that we showed earlier, essentially each FFT window indicates the vibration magnitude for a specific frequency range of a measured accelerometer signal at a single point on a machine. So the displayed bands that we have there, or frequency windows, will indicate different conditions on the machine. For example, 0.5 times the running RPM might show us machine rub. The rated RPM of the machine, a magnitude over there, might show us unbalance, misalignment at double the RPM, mechanical looseness at 2 to 3 times the RPM, and even turbulent flow or eccentric impeller by looking at the number of vanes of a fan or of a pump, and we times that by the RPM. We can also refer to these as orders. So predicting failure by trending fault indicators. Well, faults almost always propagate in a similar manner. First, they instantiate or worsen until above some level of detection. 2, they slowly propagate until end of life. How long this takes is dependent on conditions. If a machine is overstressed, under-lubricated, overheated, this step could be skipped entirely to step number 3, deteriorate exponentially until failure. Continued operation above an alarm level may result in damage to components other than the wearable component. So for example, a misaligned shaft may cause a coupling to lock up, or an unbalanced or misaligned shaft will add stress to bearings, reducing bearing life significantly. Compounded faults will cause longer and more expensive repairs, or repairs that do not actually solve the root cause of the problem. So vibration rules are well known and proven, and that's why we use vibration. If we go one step further and talk about how vibration data is actually collected and analyzed, generally sites have their own reliability team if they're big enough and it justifies that, and they collect and analyze data. Some sites have to use condition monitoring service providers that collect data, say every 12 weeks at a shutdown. And data collection is gathered manually using a portable handheld meter and then taken back for analysis. There is the issue sometimes of clients being at risk of, on the shutdown, people can't get into the area of the machine and actually get the measurements, so they might skip a round of measurements and come back the next one. Or sometimes you're also at risk if experiencing major failures in between the delay of the manual data collection and the report being presented back to say that there is actually an issue. So this leads us into talking to what makes a condition monitoring system truly integrated. So let's think of a doctor measuring your heart rate using a stethoscope at a regular checkup. You can almost see that as our handheld meter and someone walking around site. And if we compare this against wearing, say, for example, a Fitbit that gives us some live data, that's a decent analogy. If we want to apply a Fitbit type device to our machinery, then we need a way of getting the data from the accelerometer through the existing control system. I stress the existing control system because it's not truly integrated if it's not part of your control system. And I also want to clarify that I'm not simply talking about a 4 to 20 milliamp sensor. A 4 to 20 milliamp sensor will tell you when something is breaking. Essentially, it's like having a heart attack and someone telling you you're having a heart attack. It's not monitoring the actual indicators along the way. So I'll talk about the dynamics measurement 4-channel module, which you can see over here, and you can see this as the Fitbit for our integrated condition monitoring. This device is simply connected to our existing control system like any standard remote I/O would be. But this module is actually crunching the numbers. Essentially, it's converting the raw time waveform that we saw earlier to the spectrum for evaluation of those various frequency windows. The device has Ethernet connections. They're located on the top of the module. This allows for easily expanding your system. And we also have some expansion I/O that we can apply locally. So we've got an analog output. If you did need to get something to an existing DCS or control system, or a relay expansion module for expanding your interlocks, and then a tachometer. Tachometer is important because sometimes when you're doing variable speed or speed applications, you need a way of actually getting the base speed. So we've got those as expansion modules, and we can essentially provide those. So what's important to note here, though, is when we move to an integrated condition monitoring system, we don't need the tacho system. We can actually pass through the speed value that is somewhere in our control system. It can be whatever speed you're referring to, a variable or whatever you need for that specific measurement. We can pass it through to this module so that it can use it in its calculation. You'll also notice that we've got some BNC connectors over there so that, if we do have technicians that are still manually looking at an issue and they want to hook onto the system, they can simply just connect to that and get a retransmission of the accelerometer. And without even talking about integrating your condition monitoring, just simply getting accelerometers fitted on your machine and bringing it back to a central measurement point. You can understand that we have some customers that are working on massive mine sites, and on these shutdowns, it's not possible to get people into the area. So just installing a simple junction box with accelerometers enables technicians to read at any time. And then if you wanted to apply the Fitbit to that, it's ready to go. Moving on to talking about what makes a condition monitoring system truly integrated. Well, we have to detect with the dynamics module, and we have to detect the fault indicators that we spoke about earlier. So we can do 8 fault indicators per channel, 4 channels on the module, 8 fault indicators per channel. And these are simply presented as tags that are served on common I/O via Ethernet IP. A lot of our audience today might not know what a PLC program looks like, but essentially what we're looking at there is the frequency window has been translated into PLC tags, and there's a value there that we can essentially look at and monitor and tell you when something's in trouble. The nice thing about it being inside your control system or your PLC, we can apply if-then logic. I've spoken to a lot of customers that say, look, when a valve is open, we get different process conditions, or when there's a machine crushing next door to the process that we're doing here, we're not going to get an accurate measurement. We can apply if-then logic, and this is easily modeled within a controller. And then, of course, we need to monitor. It doesn't make sense that we've got all this data and we don't do anything. So trends and limits are used to monitor the propagation and then severity of faults. And we need to present this in a meaningful, intuitive way, rather than just numbers. The numbers are still there because those are important. They're available to be trended, but presenting this data on your existing SCADA system instantly increases your reliability team by the number of operators with eyes on the SCADA system or people getting alarm notifications. I also have to stress this. Machinery protection is not integrated condition monitoring. Machinery protection is the application of condition monitoring technologies in order to mitigate damage to the machine. A machinery protection system is not required to provide early indication of faults or to identify what the fault is. Its purpose is merely to mitigate the damage in the event a fault occurs. Consequently, when monitoring vibration, protection monitors usually measure and act on only the overall vibration level while assuring fast, reliable performance. Baseline values. Where do these come from? So baseline vibration values are required for an important snapshot of the relevant critical asset that we're considering for integrated condition monitoring. Now, this data is used to evaluate the asset's existing condition, understanding that we have a lot of machines that are not greenfield installs, or we have a lot of brownfield sites that have machines running. So this will also help you identify if we have existing conditions that require immediate remedial action. And if not, then we can simply use these baseline values to trend going ahead, but at least we get the snapshot of where the machine is. So like I said earlier, we have sites that have got their own reliability teams that are actually tasked with going to get this data. So it's actually available on hand. So if you moved across to an integrated condition monitoring system, the baseline values are already there. Or people use a third-party contractor that can provide baseline values taken from handheld measurements. So shown on the slide here, I want to talk about an example topology. And also want to talk about NHP's journey on offering integrated condition monitoring. We have been offering this product for many, many years, but what we realized when we really started focusing on selling this product was that we needed to give a full offering. So initially, we have all of the sensors, we have the handheld units, we have the Fitbit gear, but essentially we need a way of making it easy for customers. There are customers out there that just want to simply order a system and know that it will work. So if we look at the topology over there, it starts with the accelerometer, and that's connected to the machine. That gets brought back to either a junction box for that ease of maintenance periods like we mentioned earlier. Remember, the steps to an integrated condition monitoring don't necessarily have to go straight to the Fitbit. You might consider just making it easy for people to actually measure signals initially. But in this case, we're actually bringing it back to an NHP built enclosure. So that enclosure can contain anything from 4 to 20 accelerometer and or temperature. Sometimes we also measure temperature of bearings. And you can order that as a single part number from NHP. The benefit of that is it contains everything that you need to essentially connect to the machine on the left-hand side, but then for connecting it to our existing control system. So when we connect to our existing control system, we're essentially using a compatible RS Logix 5000 or a Logix Designer in Studio 5000 as it's been known for the last few years. And we can simply add it like a remote I/O module. And what happens then is we use an add-on profile within the PLC programming environment. So think of an add-on profile like a configuration template where you can simply put those values in. So once we have the required FFT bands for each channel, the vibration values are there inside the PLC. And then once they're in the PLC, obviously we can start doing things like pushing them to historians or to SCADA screens. But what's also important to note over here, in parallel to that, we could also be logging that data. So when I say log the data, I'm referring to the raw time waveform. Because when you have an issue and you actually want to dive deep into that and look at the data, you might need the raw time waveform of that machine for the last year to see what it's been doing. So that data can be logged separately on a separate database, in addition to that communication channel to the PLC. So to talk about NHP's offering and what we can do, we can essentially offer you the accelerometers. We can offer you an enclosure that the ICM is actually built into, a stainless steel slope-proof enclosure. And then we can also offer the service of getting someone to come and do the baseline values for you. So we're not specialists in going to do that. So obviously we have partners that do that. And how we've done that is we're the sole distributor for Rockwell, and Rockwell have formed a strategic relationship with Wood Group, who do this on a day in, day out basis. It's what they specialize in. So all we do is we make it easy for the customer. You can either get someone to get your existing baseline values, that's fine. The advantage of using NHP is you can give us an order number that we can get you a field service engineer through Rockwell, and that will actually get presented to you in the required add-on profile friendly format. So think of getting the report back. These reports are usually extensive. They have all the spectrum readings, but at the end of the day, all that's important for you is to be able to say to your control systems engineer who's setting this up in the PLC, I need these values set up. So we'll provide you with an add-on profile friendly format that you can simply set up those values. And then once you've done that, you're on your way. And I will specify integrated condition monitoring is not going to be on those low-level assets. These are the ones where you might have had catastrophic failures previously where the guys did some manual data collection. So there is some thought put into it, but essentially that's what makes up our Fitbit. So what I'm going to do now, just to kind of bring it all together for us, I'm going to play a video. And just keep in mind, like I said earlier, that media might pop up automatically, or if it doesn't, just use the icons at the bottom of your screen, and you can simply bring it into view or out of view. So folks, that's a really nice overview of what an integrated condition monitoring system can look like. I'm now able to answer any questions that we may not have answered during the presentation, and I'll ask our producer to ask any of those now.
Thanks very much, Evan. Amazing presentation, very, very informative, actually. So everyone, my name is Daniel Nathanson. I'm the commercial engineer at NHP, and I've been producing this webinar for Evan, making it go live. So I hope everyone's been enjoying the new platform. So Evan, we have had a few questions that have come through that we didn't answer during the webinar. So we have one question, which is, can you use proxy sensors for the speed reference, or does it need to come from the PLC or the process?
That's a fantastic question. Thank you, Daniel. So on board the actual measurement module, we do have TTL or transistor inputs that are capable of taking proxies. So if customers have proximities that are picking up a flag at the end of a machine, that is no issue at all. We can simply connect that, and then we can obviously apply some phase analysis to that signal as well. So no, we don't have to bring that across from the existing PLC. We can connect a prox directly to the measurement module, no problem.
Thanks, Evan. We've had another question come through, which is the video that just played shows other modules mounted on the DIN rail. Can you give us a bit more information on what these other modules are?
Yeah, no issue at all. Also a very good question. So we have varying degrees of integrated condition monitoring where customers might want to start off and say, look, we don't have Logix 5000 controllers. We just want a standalone system. So we need to be able to offer the expansion I/O in the form of, for example, an analog output where you could retransmit, for example, a 4 to 20 milliamp signal on the overall condition of what's actually happening connected to the dynamics module. We also have some expansion relay modules. So there is a American Petroleum Institute standard which requires a fail-safe relay, which is on board the dynamics module. But then we also have some expansion relays. So if it wasn't connected directly to your control system and you needed an extra few relays for interlocking, or shutting things down, you could do that. And then, of course, the other one is the tachometer. So if we weren't bringing values from the existing control system through to the dynamics, if you have any kind of application where you're measuring frequency, you have to understand what the base speed is. I used that very funny example earlier of modifying my push bike as a child, but essentially to evaluate what's going on, picture your older sibling pedaling a bicycle much faster. We need to know what that speed is to then do the frequency window. So that's what we use the tacho module for. So you grab a tacho, which measures our speed, you connect the tacho to that, and that tacho signal is then available for the number crunching within the dynamics module. So those are the modules that are available. But please understand that if you have an existing control system where you have I/O signals and you connect this dynamics module on Ethernet IP, those all become transparent in the PLC, where you can do I/O marshalling within code and that kind of thing. But it's important that we have the expansion ones in the event that customers don't have that tight integration.
Thanks, Evan. This is fantastic because we've got a lot of questions coming through for you. We have another one. Can you integrate the alerts into third-party platforms like Microsoft and ServiceNow?
Aha, that's also a very good question. So what we do is, and what we see is, as we become more and more integrated, and I've always enjoyed this with the Rockwell platform. Rockwell designed their gear around the Logix 5000 essentially being the nucleus of their universe, and we understand that all of the products around it are simply just a right-click add. So I'll take you through the steps. If we were looking at alarms and we wanted to get those into a third-party system, out of the box, the Dynamics module is not going to be pushing things to clouds or anything like that. So there's a couple of things we can do. The Dynamics module is capable of actually having its own custom thresholds and alarms programmed within the module. We need that for when the system is used as a standalone. But understand, as soon as we get this into a control system, then it's limitless. If we need to get this into any third-party system, the connectors are endless. So I know it's a bit of a catchphrase, and it has been, but the IIoT is becoming more and more tangible as we proceed. So, for example, if any of these alarms or anything need to be pushed out, picture your current control system and the capabilities that it has. If it's a simple control system and it can simply push things through to a Storian or a SCADA alarm system, that's one side of it. But then to add in a Azure connector via PTC or ThingWorx, which is our IIoT platform, that becomes really, really easy. So the answer to the question is it's limitless. We just have to get it tight into the control system. And once we have it there, we can do whatever we want with the values. So if people are asking if we can put those on cloud systems, if you are currently using a cloud system that is connected to your control system, we are connected to that control system, the answer is yes. If you don't have that infrastructure, we can certainly show you how to do it. No problem at all.
That's great, Evan. This is another question that I guess ties into the last one is, can you connect the Dynamics module to a non-Rockwell or non-Allen Bradley PLC or platform?
That is a fantastic question. So what I will stipulate here is I often have this, it's quite a comical conversation because, again, I will say that the Rockwell guys, being an American company, they don't often understand why customers would want to use other products other than their PLCs if they were, for example, using integrated condition monitoring. Now, we understand the Australian market very well. Yes, we have a massive market share here, but we have lots of customers that are using other control platforms. So the answer is yes, we can talk to those existing control systems. But in this scenario, you have to see, because of the tight integration, we need the programming capability of the Rockwell PLC to configure that module. So customers say, but Evan, that becomes a really expensive programming module. Well, I then challenge that. So I'll give you an example. Let's say, for example, if we take one of the other massively known brands and we were to integrate into any of them using any communication protocol. Think of it this way. Gone are the days where we have old serial, and I know some customers might laugh at this on the call. I know that there's a lot of sites that still use legacy protocols. There's a lot of sites that still are operating on old hardware, but this is where it becomes powerful. Let's say, for example, you have a third-party control system and you put our integrated condition monitoring system in. We would then say you need at least one Logix 5000 PLC to be able to configure that. People then say that's an expensive programming cable, but I challenge that. I say, okay, yes, it is a programming cable, if you look at it that way, to set up and configure and tweak that. But then if you wanted to use that as a mailbox to your existing control system, so let's say you had a control system that was capable of speaking Ethernet IP, most control systems are, you could essentially use that programming PLC or configuration PLC as part of your ICM system to say, okay, not only am I using this to configure the accelerometers via the dynamics modules, but I'm then using it to push the data across. And what I will say for a lot of our competitors, to make changes often, you need to take the control system offline to be able to download configuration changes. A lot of vendors are like that. There's some of our gear that requires that. But for the most part, we can right-click and add while we are running. So think of our configuration PLC as actually enabling your operation to say, okay, if your reliability team identify that they need to make a tweak on a frequency windows, they can do that online to our PLC without stopping production. And if you set up the third-party control system in a way that you have a massive structure of arrays that are just there for the data to be pushed across, we can actually do it without taking the system offline. So the answer is yes, and we can provide some improvements by doing this by not taking the system offline. I hope that answers the question, Dan.
I think it does. We are getting a lot of questions flowing through at the moment, and I hope we have time to answer them all. So,
absolutely.
Evan, I'll just keep them coming. So we've got another one over here, which is, can you extract the spectrum from the Allen-Bradley modules?
That is also a very good question. So how we do that, and where I showed in the topology earlier, we can actually take this raw time waveform data and spectrum data, and we can log it into a separate SQL database. The reason we do that is we actually have an analysis software, which I won't be covering today. Obviously, if there's demand for that, we'll have another webinar for the series. But we have an analytical software called eMonitor, which essentially supports the dynamics module. So think of it this way. If you have one of our handheld meters and then you basically add on some dynamics, we can set the eMonitor to go at a scheduled basis and go and grab that data in the form of the snapshot of the spectrum at the time and the raw time waveform. So the benefit of that is if you have the raw time waveform in some analytical software, you can essentially do the spectrum analysis there, or you can let the FFT be carried out in the dynamics module and then just grab a snapshot of that. So the benefit of that is then your reliability team has a database that they can start looking into things, because quite often when something goes wrong, it's not where you want to hit the alarm bells and shut everything down, but someone can actually go there, measure with their handheld, someone can jump on the eMonitor and analyze the software as well. So absolutely we are able to extract the spectrum, but we have to use it using our compatible software called eMonitor with the product, Dan.
Thank you, Evan. Couple more questions. I suppose this one's more in terms of the hardware capabilities. So we have another question, which is, can the dynamics module be used with triaxial accelerometers, rather? And I believe those are the ones that will operate in the X, Y, and Z axes in just one particular sensor. Is that correct, Evan?
Yeah, 100%. So what I will say is that tri-ax sensors, the use of them has definitely come a long way. And if we think about that, so Dan basically mentioned measuring in different planes. So if you just picture, if you have a gearbox, and it's driving whatever, a pump or a fan, so we're essentially measuring at each stage of that machine. So it might be the non-drive end and then the drive end. And along the way, what we want to look for is the strongest transmission point. But now when we look at these measurements, what happens is you might, for example, if you were looking at the Z plane, you might pick up looseness easier than on the X plane. So quite often it's not economical to put 3 sensors on every single plane on every single position. So there's rules for that. Essentially, we'll pick the transmission point that picks up a bit of each. But if you had a triaxial sensor and the accelerometer was giving you 3 raw signals, that triax sensor would essentially need to consume 3 of our channels. So the channel can be configured for a millivolt signal from existing accelerometers. And if that's a triax sensor, you would need a way of getting that with 3 measurements to our module. So it doesn't support any kind of custom comms. If a triax has some clever protocol, it doesn't support that. But each channel can be configured for a DC signal, for example, for an eddy current. If people are doing journal bearings, you need an eddy current or a DC input. And then we can also do temperature, and then we can do the vibration. And I will just add on to this. Quite often people look at a dual purpose accelerometer. So this is just moving slightly away from the triax. If you look at a dual purpose accelerometer, it's doing temperature and it's also doing vibration. So quite often customers don't see the value of buying a dynamics module and using one of the channels for temperature, because the cost of a vibration channel is much more than just a temperature one. So what we could do there is we could actually use some remote I/O, like point I/O or any of the I/O modules that we provide, and that could measure the DC for the temperature and then keep the vibration and then get value out of your system that way. So in short, Daniel, I know that wasn't a short answer, but yes, we can measure triax, but just keep in mind each plane would consume a channel, and then we can also look at other signals like DC for temperature or eddy current probes.
No, that's fantastic. Thanks, Evan. We always enjoy getting a lot of information out of a basic question, because it always shows there's a lot more to it than just a single one-sentence answer. I suppose we've also had another question that's come through that we did answer in the Q&A, but I suppose you could put some more words to it, as this does almost lead into your spiel about the triax sensors, and that is whether or not NHP can tell our customers where to place the accelerometers. Do you have any thoughts on that one?
Yeah, absolutely. So first of all, from a resource point of view, we have many application guides from Rockwell, which are very comprehensive. We'll send a link out to those with the YouTube video afterwards, and in the form of an email. So let's start with just saying we have some really good documentation, which actually steps you through every single application, like a fan or a conveyor, and what traditional measurement includes and where it goes. Understanding as well that vendors that produce gearboxes and motors often leave tabs for an accelerometer to be attached to. The thing that's important is that you need to get someone out to site that understands that if they did a handheld measurement and they need to show you where to place that sensor because of the type of machine or application, 100% we could provide that. So that was the partnership that I spoke about earlier. So we partner with Wood Group through Rockwell, and we do that for convenience, because if a customer is already an NHP customer and they are purchasing Rockwell or any of our other awesome NHP products, and they simply want to give an order number to NHP, that's why we set up that. But if you're using a third party, no problem. But essentially, yes, NHP can tell you where to put the sensors in the form of an application guide, which is just a PDF, or we can get a field service engineer to site to do the baseline values, to give you the report, and in that report, they'll show you exactly where the sensors need to be installed. No problem.
Thanks, Evan. And you did just touch on briefly about the baseline readings. So, do we offer services for gathering those baseline data collections and doing reportings? Maybe talk a bit more about those.
Yeah, 100%. So, if you are the type of customer that says, "Look, I don't currently have ICM. I have a contractor coming around, and they're just doing those measurement values, and I'd like to look at this further," you can get in touch with your local NHP sales rep and say, "Look, I've got a couple of critical assets that I need assessed." And we will easily do a proposal, which will then include the options for sensor placement, or someone coming out and simply just looking at that one machine, or looking at the site and maybe proposing a strategy around that. So we can do it in many forms. But from our services side, 100%. That's why when we started this, our confidence was only around 25%, because of course we had the hardware and the technology, but we needed a way of customers saying, "Okay, I'm ready to take the step to ICM." So talking to your local NHP business development person, or contacting us via our website or any of the other streams that you can, we can essentially come back to you and give you a proposal which will give you all of the options that you need for the baseline readings, sensor placement, amount of sensors needed, the NHP built enclosure. And when you get it in, you can then say, "Okay, I've got a control systems engineer on site that can look at that add-on profile friendly format and simply put the numbers in." Or if you're using a systems integrator, no issue. You just simply give them the report and they set it up for you, and you're good to go.
Thanks, Evan. Well, it looks like we've actually managed to get through all of the questions. So what we'll do now is, unless any more questions come through, Evan, what I might do is pass it over to yourself to sign us off.
Thank you very much, Dan. I really enjoyed those questions. That was really good. So that is all the questions that we have for today, and we want to thank you again for joining us with this webinar. We hope that you found it beneficial, and if you'd like to watch it again, recording will be sent to you via email and will also be uploaded to our NHP YouTube channel, where our webinar library is really growing. So to find more webinars in the series, simply click the button in the call to action icon section on your screen, which will take you to our website, or you can visit the link, which is our YouTube channel. Guys and girls, a short survey will pop up on your screen once the webinar concludes. We would be eternally grateful if you could just take 5 minutes to provide your feedback, good, bad, or otherwise. We need to know how we're tracking, please, folks. And please keep in mind that NHP have invested in ICM demo units and training for technology specialists nationally. So if you have any further questions about integrated condition monitoring, please contact your local NHP sales representative or jump online and get in touch with us. With smarter and faster decision-making and seamless connectivity spurring new collaboration, NHP is enabling the connected enterprise. Thank you very much.